Hello, dear students. Today in this class, we'll discuss some more problems related to the concept of displacement, velocity, acceleration of a particle which is executing the simple harmonic motion. Obviously, one question I have already written here, that is of a particle is executing simple harmonic motion with the time period 4 seconds. If the amplitude of the oscillation is a 5 centimeter, then calculate the displacement, velocity and acceleration. Particle after 1 second it start oscillating or oscillation. So in this question, particle already it is in a simple harmonic motion, the time period at 4 seconds, and the amplitude of oscillation is also given 5 centimeter. It is only thing that we have to calculate the displacement from the mean position and velocity of that particle and acceleration of that particle after 1 second it start oscillation. So this is a very important question it is, and very easy concept also to understand. That means first we have to go ahead with the framing the diagram here. That means you just take the where the particle executing simple harmonic motion when it is at the mean position at x is equal to 0 and t is equal to 0 here. So we will go ahead with the one extreme position either side, positive side and the negative side here, right? From here it is moving towards the one extreme position. I will take this obviously positive side, it is easy to understand here. So the maximum displacement from mean position to the extreme position, that already it is given 5 centimeter it is. So amplitude of oscillation 5 centimeter it is given, and time period to reach this time period t also it is given as a 4 second time period, 4 second. Only thing that we have to find out the x here, velocity and acceleration. These 3 points we have to calculate even after time period is 1 second, after 1 second when it is in simple harmonic motion. So we have, first we'll go ahead with the displacement here. X is equal to a sine omega t, a sine omega t. So this is also one of the general equation where particle is moving from mean position to the extreme position, either side, positive side or the negative side, any side it is, but it is not prescribed clearly that which side it is moving or which side it is executing the simple harmonic motion. So better we take a positive side so that it is easy to do the solution here. So amplitude is given here, that is of 5 centimeter, sine omega t. Let it be this form here, and time period it is given as a 4 second here. We have a relation that is of t is equal to 2 pi by omega. So omega is equal to 2 pi by t. So 2 pi by t, t is a 4 second. So 2 ones are 2 twos are. So remains with the pi by 2 here. That is of omega. So place this omega value in this equation 1 here. So x is equal to 5 sine omega is what here, pi by 2 into t here. So as a t is also given as a, after 1 second we need to find out the displacement, right? So x is equal to 5 sine pi by 2 into 1. So x is equal to pi by 2 is what here, sine pi by 2 is 1. So sine pi by 2 is 1. So remains with the 5 here, 5 centimeter. This is a calculated form of displacement after 1 second when particle is executing the simple harmonic motion. By checking this question itself, we can able to find out the displacement very easily. That means we know that what is amplitude. Amplitude is a maximum displacement from the mean position. What is displacement? That is also nothing but the distance of the particle from the mean position, where it is either it is in a positive side extreme position or the negative side. So x is equal to a means what here? That is nothing but the 5 centimeter only. We can write it directly here, but the thing, it has to understand whether x is equal to a or not. We have done the expression here. That's it. Clarification is more important than the imagination or the conclusion. Final conclusion we have to get it from the after doing the solution only. So we got it, the displacement is how much here? X is equal to, we got it, x is equal to 5 centimeters, same as the amplitude here. So you can write it in this short only, that itself is equal to the amplitude. That means particle is there at the extreme position. Next we'll come on towards the velocity. So velocity of the particle. So we have a general equation, velocity 3 form I have said here, which is relevant to that problem that we have to go ahead. Here we got the omega we got it here pi by 2, t is given as a 4 second, after 1 second it is given, right? So amplitude also we are having. So we are having these all things. We can make use of omega is equal to a square minus x square here. This form we can use it. This is for the velocity of the particle here. So v is there, omega is a pi by 2, root of a square is what here? 5. So 5 square and 5 square, where x is also we got it here 5 centimeter. So what we are getting? Totally 0 it is. So totally 0, correct? So that means velocity is at the which side? Velocity will be maximum at the mean position. Velocity will be 0, either it is extreme position. So velocity is there at 0, indicates here particle is at the extreme position. So this also we got it, v is equal to 0 here. So finally we have to calculate the acceleration here. So we have acceleration formula, that is of minus omega square x. If you go ahead with the modulus, we'll get it here omega square x. So we have omega here pi by 2. So pi by 2 whole square into 5. X is what here? Displacement. That is 5 here. What you are getting? Pi square by 4 into 5 here. So finally we are getting 5 by 4 pi square here, right? 5 by 4 pi square. Acceleration means it is pi square centimeter per square it is, because amplitude is there in the centimeter, displacement is also there in terms of centimeter, then acceleration is centimeter per second square. So we got it here, acceleration is how much? Pi by 4 centimeter per pi by 4 pi square is pi square centimeter per second square. So this is the expected answer. It is asked in the same problem here, where particle is executing the simple harmonic motion with a time period 4 seconds. If that amplitude oscillation is a 5 centimeters, obviously they may not ask displacement. Sometimes they may ask the displacement. So without wasting the time, you can just clarify as amplitude is equal to displacement here. Even if you want more clarification, make use of the equation and find out the solution. That means it is almost equal to amplitude only. In most of the cases, it may said as a displacement, it may said as a amplitude. Don't get confused. Both are measured from the mean position where it is the particle is there at the extreme position, either it is a negative side or it is a positive side at it. So after 1 second, where it will be the displacement, where it will, what will be the velocity, what will be the acceleration. This was asked the question here. So we got the solution. We'll move on to the next problem. The next problem is the particle executing the simple harmonic motion of amplitude 30 centimeter and the time period t is equal to 4 seconds. What is the minimum time required or the particle to move from the mean position to the point 15 centimeter? So understanding the problem is very important here. Particle already executing the simple harmonic motion of the amplitude 30 centimeter. That means it already reached to the extreme position. So by taking a 4 second, it's going to be completing its extreme position from the mean position. It is what is the minimum time required or what the particle to move from the mean position to the point 15 centimeter. So we'll frame the diagram here so that we'll get the conclusion. So particle is there at the mean position right now. So it is moving to the next extreme position, that is of positive side. Amplitude it is given 30 centimeter it is. So 30 centimeter. To reach this time period is a 4 second it has taken, right? So it is asking here what is the minimum time to reach 15 centimeter, means 15 is a half of 30 centimeter. So I'll take it as a center portion of here. From here to here, how much time it is taking to reach this amplitude? So this amplitude means that is of 15 centimeter. So 15 centimeter to reach this point. So here x is equal to 30 centimeter. Here x is equal to 15 centimeter. To reach mean position to extreme position, it is taking the time period 4 seconds here. To how much time it will take to reach? Only 15 centimeter. That was the question it is asked here. We have a displacement x is equal to a sine omega t here, right? Where omega it is 2 pi by t. So time is also given 4 seconds. That means 2 pi by 4. So 2 ones are 2, 2s are. So pi by 2 I'm getting here omega. So omega I'm getting pi by 2 here. Next substitute these all things here as x is also given 15 centimeter. Go ahead with a. X is equal to a sine omega t here, right? We want this time period here. X is given 15, a is also given here a is given here 30 amplitude. So sine omega t is what? Pi by 2 here. So 30 into t here. Sine by pi by 2 is 1. It will remains with the 15 here. So t 15 by 30 is equal to t here. 5 3s are 5 6 the 30 here. So 3 1s are t2. 3 2s are 6 here. So t I am getting 1 by 2 second. That means it is taking 0.5 second here. So that means to reach 15 centimeter it is taking the time period 0.5 seconds it is. So this is the question it is asked here, how to take the solution of it. So before going to the exactly application of taking the help of equations, general equation of simple harmonic motion, first we have to understand the questions very properly. What particle is executing and in which required time period or the amplitude, what we need to calculate. So there was first we have to conclude that what to need to calculate. Later we can apply the equations. To understand this question, better go ahead with the diagrammatic representation. You have to frame the diagram relevant to the problem asked here so that you will get a correct conclusion which form of displacement or velocity, acceleration or anything else they are need to calculate here. We can able to use it the equation. We'll move on to the next problem. So in this problem, instead of taking the body here as a suspended from the rigid body, they have taken a spring here. So a body of a mass 1 kg is made to oscillate on the spring of force constant 9 Newton meter here per meter. Calculate the angular frequency of a oscillation. So using a spring, we'll take some more problems in the upcoming classes also. This is the beginning. So I have taken the this problem here. So already here we has to use only the thread here where the bob is suspended. Here now they have taken the spring and it is over suspended 1 kg here. This spring has a force constant they had given already, it is minus kx. This we know from the restoring force. Spring constant or the force constant, the force is K will represents the force constant here, that is of 9 Newton per meter. It is restoring means it is coming and going, so moving up and down. This execute the oscillate here on the spring of force constant 9 Newton per meter here. Here we need to calculate the angular frequency. So where angular frequency, by knowing that it is of 2 pi f, again we have 1 by t. So it will give the same meaning of 2 by pi t here, right? So this form we have to calculate. This is only asked in this question here. As we know here, mass of the body is a 1 kg. Then K is equal to what here? 9 Newton per meter. As we have the omega is equal to, in simple harmonic motion, what is that? Root of K by M. You can calculate here. Minus Kx here in simple harmonic form. In the first video class only we have discussed if body executing simple harmonic motion means it should execute this force. So we know this one. When you compare with the force which is acting on the body, we have acceleration is what here? Force by m. So F is what here? K by m here, that is of x, right? When you substitute here, we'll get it minus K by m. So that's why we are getting minus omega square x. So omega square is what here? K by m. So directly I have written here omega square is equal to K by m. Omega is equal to root of K by m. So we need to substitute here. Omega is equal to root of K by m. So K is already given, that is of 9. Root of 9 by kg is what here? 1. So root of 9 is a 3 here. So 3 radian per second. Radian means what here? Omega, they have taken it as a angular frequency. Angular frequency means it will come it as a radian per second. So this is the expected answer here. Only thing that we need to understand which one we have to apply. That's it. Nothing is there to do the solution. Understanding the problem by doing the diagram here. Those who are very perfect in understanding the problem itself, we can go ahead with directly applying the formula and find out the solution. Those who are getting little bit confusion how to apply the given concept in the required data or required point of in the problem here, what to calculate, how to calculate, better you go ahead with the first framing the diagram only. As soon as you frame the diagram, that indicates here you have understood the problem. And if you do the minor mistakes in problem in drawing the problem also, you will get to know that. So what they have asked, what I am doing, Then later you will make a correction and you will go ahead with the application of the concept, and you go ahead with the what they have asked to solve it. So we will going to finalize that problem. So by this we'll go ahead with the one more very important problem here. So we'll go ahead with the one more problem, that is of Bob executing the simple harmonic motion. Bob executing simple harmonic motion, right, of a particle 20 second. Its velocity is 5 centimeter per second and 5 centimeter per second 2 seconds after it has passed the mean position. 2 seconds after it has passed the mean position. So mean position. Find the amplitude of the bob. So find the amplitude of the bob. So very simple problem it is. Only thing that Bob is executing the simple harmonic motion. So this is of Bob executing the simple harmonic motion to and fro motion on positive extreme position and the negative extreme position. So that means it is moving from here, here and here. So one oscillation it is. So here and here. This is a second oscillation. So like that it is executing the simple harmonic motion here, right? Its velocity is also given, that is of 5 centimeter per second, right? In time period t is equal to 20 second it is, right? So we need to find the amplitude. So amplitude of the particle when it is executing the simple harmonic motion, that only we need to calculate here. That is the question asked. So we have x is equal to displacement a sine omega t here. We'll go ahead with omega is equal to 2 pi by t here. So t it is already given 20 second. So 2 pi by 20 here will get pi by 10 radian per second. It is omega. We got the value here. And we need to find out here x is also given amplitude. No, x only we have to calculate here, right? Now with the help of velocity we'll go ahead at, because velocity is given, right? That is of here which form we have to use. Omega is there, a is not there, right? Then we can't use the omega is equal to omega root of a square minus x square. That is not valid. So we'll go ahead with the a omega cos omega t here. So a omega cos omega t here, because we have omega form. A is there here, velocity is given 5. Velocity is given 5 here. And write it. Omega is pi by 10. So let be cos pi by 10. So t is after 2 seconds, which passes through the mean position. So after 2 seconds or 2 seconds after it has passed to the mean position, 2 seconds means one oscillation. So 1 second for 2, another 1 second for fro motion. After one oscillation it is reaching to the mean position. So there we need to find out the amplitude. Same thing I have written here. That wise t is equal to 2 seconds. T is equal to 2 seconds. It is got it here now. 2 ones are 2 5s are here. A into pi by 10. I think camera is not catching here, so I'll write it. So 5 is equal to a into pi by 10 cos pi by 5 it is. So cos pi by 5, we got it here. Cos pi by 5 is nothing but the what we are getting. Let us cross check here. Pi is 180 by 5 it is. So it means cos pi by 5. I am expanding it as well as 5 ones are. So 5 3s are 15, 16, 17, 18. 3 here we are getting. So 36. So cos 36 degree we are getting. That is pi by 5 here. That means 5 a into pi by 10 cos 36 degree it is. So cos 36 degree you can make a help of your class table or the logarithmic table. You will get to know that what value is you are getting. Now I am directly writing this value here. So we need to calculate a no here. So it will come as 5 into 10 divided by 5 into cos 36 degree here. So cos 36 degree. So amplitude is equal to what here? 50 by pi is 3.142. So cos 36 I am directly writing 0.8 0.8090. You can make a use of Klux table. You know how to use it. Cos 36 natural cosine, you have to go ahead with that. In that degree 36 relevant to the row corresponding column, you have to cross check with a zero minute only. First column you have to go ahead with that, where you will get a 0.8090, that cos 36 value it is. So there we are getting, by doing calculation we are getting amplitude is 19.67 centimeter it is. So it will take the 19.67. To reach this one, they had not given what is the exact extreme position amplitude it is, but we need to find out the amplitude of after 2 seconds when it reached to the mean position. That means after one oscillation it is coming to mean position. That mean position value is 19.67 centimeter here. So this is the expected answer for the question here. So like this you will have a plenty of problems, plenty of questions here where we need to calculate its velocity, its acceleration, its amplitude, displacement. So relevant after sometimes after some distance from the mean position. In that mean position, if you suspended the spring, so like this you will get a plenty of problems. You can collect the problems from the other books also. So I have utilized here many other books. So you can also take help of other books here. You can go ahead with the errorless, Cengage, whatever it is which is comfortable for you. Collect those kinds of problems, try to solve it, so you'll get the confidence in the concept. Is we can able to attempt these kind of problems in the examination. Only thing that you need to understand the problems very clearly. So until you get a clarification what to calculate in the question they have asked, later you can apply the whatever the concept we have discussed in the previous class, general equation to find the displacement, velocity, acceleration. So make a list of it, and you can try to solve it. So you will get the, based on this chapter, based on this concept, whatever we have discussed, we'll get the assignment also. So that assignment problems also you can able to solve it among yourself. Sit properly and understand the concept. Later you can go ahead with the solution of the problems. You will get a very feel that it's easy concept it is, and enjoyable concept when you can attempt for the different kind of the competitive exam. Similarly, you will have a different concept here, that is will understand the phase diagrams, will understand the graphical representation of the simple harmonic motion, its energies. These all concept we are going to discuss in the upcoming classes here. So by this we'll go ahead with the problem part. Whatever the concept we have discussed from the previous classes here, those concept I have solved the problem here. It is not enough things, it has the extension part of the problems. It is collect the different form of problems, as much different types of problems I have selected here, and I have solved you how it is possible to do the solution here. That is very important. And the thing is, before going to the solution of problem, in your mind you should have the uh, note of it. Note in the sense what? Varieties for different form of the solution, I mean different form of the equation. In the same part we have the velocity, we have a different three forms. So as we know here, v is equal to omega root of a square minus x square. One form is there. Velocity a omega cos omega t is there. That means a omega cos omega t plus phi is there. So acceleration we have omega minus omega square x is there. So acceleration we are having a minus a omega square sine omega t plus phi. So these things, so different forms, see these are the different forms to find out the velocity. So these things you should remember. This is a different form of the acceleration, but both are giving whatever may be the form, the acceleration or the velocity, and displacement. So you can go ahead and a sine omega t is there, and a cos omega t is the different form it is, right? You will have a sine omega t plus phi. So these are the forms of the other things it is. So don't get confused how to apply, how to solve these problems. These are the convenient way to solve the problems. How it this form came, how this form came, how this form came, we already discussed these things in the previous classes here. So once you go through it, make a list of it. So which form we are applying to solve the problem, what they have asked. If the given data omega amplitude x is there, no need to take these two. It is there already, prepared food is there, just have it and enjoy it. So you just take it and substitute and find out the velocity and the acceleration, whatever it is, you can make use of these things. So this is the conclusion I wanted to give you, that make a list of formula. No need to bad the formula here. You need to remember the problem, formula here. So how to remember, that is the best way is understand it, how these formula comes. Once you understand how these formula came, it is no the question of beheading. Still if you are getting confusion, still if you are getting the difficulty to remember, means make a list of it and remember before going for the solution, until you get practiced of not to see these kind of form here again and again while solving. Just to make it list, keep it aside, give for the solution. So in the next upcoming classes, we'll discuss some more interesting topics, that is of phase diagram, energies. So these are all things we will going to discuss.